Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in this lecture, that is conversion of Moore to Mealy machine, we are going to understand how to convert a Moore machine into its equivalent Mealy machine. So the topic for this lecture is conversion of Moore to Mealy machine. Now it is to be noted that the computational power of Moore machine and Mealy machine is the same. That is why one of them can be converted into other. So in this lecture, we will understand how to convert a Moore machine into its equivalent Mealy machine. And in the next lecture, we will understand how to convert a Mealy machine into its equivalent Moore machine. So let's get started with our very first problem. Construct a Moore machine that prints A whenever the sequence 10 is encountered in the input string. Otherwise prints B. Also convert it into its equivalent Mealy machine. So this question is divided into two parts. In the first part of the question, we are required to construct a Moore machine that will generate the output symbol A whenever the sequence 10 is encountered in the input string. Otherwise, it will generate the output symbol B. And in the second part of the question, you are required to convert the Moore machine that you have constructed in the first part into its equivalent Mealy machine. Now, the first part of the question we have already completed in our previous lecture. This is the required Moore machine that will print A whenever the sequence 10 is encountered in the input string, and otherwise it will print the output symbol B. So if you have any problem regarding the construction of this Moore machine, kindly refer to the previous lecture. Now let's come towards the agenda of this lecture, that is converting this Moore machine into its equivalent Mealy machine. Let's see. To convert this Moore machine into its equivalent Mealy machine, we are required to shift the output values from the states to the transition arrows based on the destination state. What does that mean? You already know that in case of Moore machine, the outputs are written along with the states. But in case of Mealy machine, the outputs are written along with the input symbols over the transition arrows. That is why to convert this Moore machine into its equivalent Mealy machine, we are required to shift the output values from the states to the transition arrows. But it is done based on the destination state. Let's see how to shift the output values. Consider this particular transition. For this transition, this is the source state and this is the destination state, because this transition is emerging from this state and coming towards this state. That is why this state is the source state and this state is the destination state. And according to the statement, we need to shift the output values based on the destination state, which means the destination state has the output symbol B. That is why for this transition, the output symbol will be B. Now let's talk about this transition. For this transition, this is the source state and this is the destination state. For the destination state, the output symbol is A. That is why we will write the output symbol A. Now for this transition, this is the destination state having output symbol B. So here we will write B. For this transition, this is the destination state having output symbol B. So here we will write B. Now let's talk about these two transitions. For this transition, which is a self-looped transition, this state is the source state as well as the destination state. That is why the output symbol will be B. For this transition also, this is the source state as well as this is the destination state. That is why the output symbol will be B. So this is the required machine that we have obtained till now. Now let's read the next line. Then remove the outputs associated with the states. Now we have to remove the outputs associated with the states because we have already shifted these outputs onto the transition arrows. Now after removing these outputs, we will get our required Mealy machine like this. So this is the required Mealy machine that we have obtained after converting the given Moore machine. Now let's see one important point. In Moore to Mealy machine conversion, the number of states remains the same, which means while converting a Moore machine into its equivalent Mealy machine, the number of states remains the same. In the original Moore machine, it had 3 states. And you can see in the resultant Mealy machine also, we have 3 states. That means the number of states remains the same when we convert a Moore machine into its equivalent Mealy machine. So in this way, we are done with the problem number 1, in which we have first constructed a Moore machine and then we have converted that Moore machine into its equivalent Mealy machine. Now let's proceed towards the question number 2. Convert the given Moore machine into its equivalent Mealy machine. So this is the transition table of Moore machine that is given to you. And now you need to convert this transition table of Moore machine into its equivalent Mealy machine. So this is the Moore machine that is given to us. And now we need to create the basic structure of the transition table of the Mealy machine. So this is the basic structure of the Mealy machine transition table. In case of Moore machine, the next state is determined by the present state and the input symbol, but the output is only determined by the present state. But in case of Mealy machine, both the next state as well as the output symbol are determined by the present state and the input symbol. That is why this is the transition table structure of a Mealy machine. Now we need to fill all these entries. So Q0 on A gives Q1 and Q0 on B gives Q2. So Q0 on A gives Q1 and Q0 on B gives Q2. The next states remains the same, similar to the Moore machine. Now Q1 on A gives Q3 and Q1 on B gives Q2. So we are getting Q3 and Q2. So here also we are getting Q3 and Q2 as the next states on input symbol A and B. For the state Q2, the next states are Q2 and Q1. So here also we will write Q2 and Q1. For the state Q3, the next states are Q0 and Q3. So here also we will write Q0 and Q3. Now we need to determine the output symbols. So here, the output symbol associated with the state Q0 is 1. The output symbol associated with the state Q1 is 0. For the state Q2 is 1. And for the state Q3 is 1. So here we need to fill the output for the state Q1. For the state Q1, the output is 0. So here we will write 0. For the state Q2, the output is 1. That is why we will write 1. For the state Q3, the output is 1. So here we will write 1. For the state Q2, output is 1. So here we will write 1. Next, Q2. So for Q2, the output symbol is 1. So here we will write 1. For the state Q1, the output is 0. So here we will write 0. For the state Q0, output is 1. So here we will write 1. For Q3, output is 1. So here we will write 1. In this way, we have completed the Mealy machine transition table. So the output column we have filled using the outputs associated with the states. So whatever the states we are getting as the next state in the Mealy machine, we have written the output symbol by checking the output symbol associated with the present states of the Moore machine. So this is the Mealy machine that we have obtained till now, and now we will convert this Mealy machine transition table into its corresponding transition diagram. Let's start with the initial state, that is Q0. This is the initial state Q0. Q0 on A gives Q1 and output symbol 0. So Q0 on A gives Q1 and the output symbol 0. In case of Mealy machines, the output symbols are written along with the input symbols over the transition arrows. Now, Q0 on B gives Q2 and output 1. So Q0 on B gives Q2 and output 1. Q1 on A gives Q3 and output 1. So Q1 on A gives Q3 and output 1. Q1 on B gives Q2. Q1 on B gives Q2 and output 1. Q2 on A gives Q2 and output 1. So Q2 on A gives Q2 and output 1. Q2 on B gives Q1 and output 0. So Q2 on B gives Q1 with output symbol 0. Now let's talk about the state Q3. Q3 on A gives Q0 and output 1. So Q3 on A gives Q0 and output 1. And Q3 on B gives Q3 and output 1. Q3 on B gives Q3 itself with output symbol 1. So this is the required diagram of Mealy machine that we have drawn on the basis of the transition table of Mealy machine. In this way, we are done with our topic, conversion of Moore to Mealy machine. In the next lecture, we will understand how to convert a Mealy machine into its equivalent Moore machine. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.